Hi, this is Margo. This is Monday, May 28th, 2018, and this is my weekly update. I'm a couple of days late getting this done, but anyway, it's my weekly update on greenhouse gases that are in the atmosphere, specifically methane, carbon dioxide, and I am going to include sulfur dioxide briefly in this video as well. If you have not seen my sulfur dioxide and volcanic gases part 1 video that I did earlier, well, last week, I think it was on Wednesday, go ahead and watch that, and that's really interesting. I went into what kind of toxic gases come out of volcanoes and what happens when it comes up in the atmosphere and how it disperses. And it's actually you can track it on cams on this website that I've been using, Copernicus Atmosphere Monitoring Service, which is the website that I'm on right now. And it's pretty interesting, and I'm going to be doing a part 2 of that video where I talk more about volcanoes and underwater volcanoes and things like that. But today we're going to focus on methane because that's what people are really interested in, and carbon dioxide. And before I get started, I have another announcement. In case you're not aware, I'm going to be doing another interview. This will be my second one with Dr. Guy McPherson. It's going to be on Thursday, May 31st at 2 p.m. Pacific time. It's going to be a live call-in show. I made a video last week announcing it with all the details, so if you would like to listen or participate in that interview, that show, you can call in. It's going to be a conference call type setting, and if you're not able to call in but you do have questions of Dr. McPherson, just put them in the comments section below, and I'm gathering the questions and will be asking him questions during the interview. So that's on Thursday this week, and we're going to be talking about mainly about methane and digging into methane and all your different questions about methane, and then other questions about abrupt climate change. And I'm going to be asking him also if he thinks this recent volcanic activity in Hawaii is related to abrupt climate change. So we're going to be covering a variety of topics, and of course I will make that into a YouTube video and put it up as an archive, so if you missed the live show you'll be able to hear it here on YouTube. I also have a BitChute channel, and it'll be up there, and it will also be archived just as an audio podcast on my website, margoshealingcorner.com. So enough of that, let's get started. This is a different worldview, and I'm going to show you how to get to this worldview on the CAM's website, and how to make the movie here. I like this one because it goes back, like this is the 28th, and it goes back, the data goes back to the 23rd. This is actual data from the 23rd through today, and well, this is UTC time, and then you can run the movie. This is global methane, and it's at surface level, and so you can switch and see it at the different levels here. You can do total column. If you click on total column, it reads it the whole column level, and we'll let that load. It's not loading. Well, let's just, I have trouble when I start doing the movies or doing the videos. Let's just leave it at that, at surface level, because that's what's working for me right now. And then we can run the movie and see, get an overview of the world and how the methane levels have been. It moves a little bit slower on this movie, and you can zoom in, you can zoom out. I zoomed out so we can get a better picture of what's going on up here in Alaska and in Russia, because you can't really get a really good view when you go in closer. So this is methane, and it's pretty hot out there. It's not as bad as it has been. I don't know if it's because we've had some cooler temperatures in the northern hemisphere this last week or so, but it's still popping up, especially up here off of England, out of the ocean, and off of the coast of Norway, and it's still coming up. You'll see it when the movie starts over. It's about to start over. You see it coming up off the coast of Russia here, Siberia. And this is Novaya Zemlya, which is that the island off the coast of Russia, where the climate scientists have been watching it pop up on either side, and so we can look at that. And here's the East Siberia ice shelf. It doesn't seem to be as active this week as it was last week, but you know, this comes and goes, it fluctuates. So I'll show you how to get to this view. If you go, here's the home page, and you just click on any of these pages. If you just click on the home page, you'll go to the home page of CAMS, and then you come down to catalog and hit enter. And if you've been here before, it remembers your settings and your cookies. And my settings here were for global forecasts, and I clicked parameter family. I clicked aerosol, greenhouse gas, radiation, and reactive gas. And then you can choose any of these, and you can look at fires, you can look at solar radiation, you can look at propane, ozone, carbon, you know, all of these things. And I mean, it's just a whole wide range of things you can look at, but I've narrowed my focus down to carbon dioxide, methane, and sulfur dioxide. And these are the results that we can look at. And so if you click on like methane, you want to see global forecast for methane. If that doesn't work, sometimes you have to click there. Sometimes you have to enter the catalog again, like from up there at the top, and then it'll work. See, when I'm trying to make the videos, it doesn't work. It works when I'm not doing these videos for you guys, and then it won't work when I'm doing the videos. I don't know why that is. I really don't know why that is, except, well, you know, I have my own theories, But anyway, let's try going to the catalog from here and see if we can. Oh wow, I've got to put my parameters back in, see if we can get this to work while I'm recording. That would be a first. Sulfur dioxide. Okay, let's go. Let's see if, here we go. Yeah, I just had to reload everything. Here's carbon dioxide. And then you go down to plots and you load the plots, and here you go. Here's the whole world. Folks, that's not looking good. It's totally not looking good for carbon dioxide around the planet. This is total column. This is parts per million. And then here's your chart down here with what the colors mean. And green, this chartreuse right here is at 407 parts per million. And then when it goes into yellow, it's 408. This kind of gold color is 409. The orange color is 410. When you go into red, it's 411. And then darker red, 412, 413, 450, and then it's hard to tell, 415, and then the black skips to, it looks like 500 to me. It looks like they didn't have room to put all their numbers there. This is column, so it's measuring the whole column from the surface up through the atmosphere. And if you want a wider view so that we can really see what's going on up at the Arctic and the Antarctic, you can do that. You can move it, just grab it with your mouse here. And that's not looking good, folks. So when they say that carbon dioxide is at like 410 parts per million, that's an average around the world. That's an average, and a lot of the northern hemisphere, in fact most of the northern hemisphere, is above that, as you can see here. And even at the Antarctic, it's at this blue-green, it's at about 402 parts per million, and then it quickly goes up from there. It goes up to the green, and as you go farther north on the globe, it keeps increasing until you get into the northern hemisphere, where most of your industrialized civilizations are, and burning of fossil fuels and things like that, and it's giving off all this carbon dioxide that's hanging around for a long time, and that's heating up the atmosphere and heating up the planet, along with methane. And then you've got your sulfur dioxide too that I'm studying. And so you've got like India over here that's really high. It's densely populated. And then you've got China and East Asia. They have lots and lots of carbon dioxide coming up. And then you've got parts of the United States that have a lot. It's not quite as heavy as over in India and China, but it's not good either. And then, you know, you do have pockets where it's just gold up here in the northern hemisphere, just gold and yellow, but that's still really high. That's like 409 and 410. So I rewound the movie to reset it to May 23rd, and then if you hit the play button, it'll load it up and show you the carbon dioxide. And I read somewhere that when they're measuring carbon dioxide total column, that they can't measure it at night or if there's cloud cover, like the readings don't come through. So that's why it might be fluctuating. Like if it's daytime, it might be higher than at nighttime because they can't get the readings. It has to be bright sunshine. It has to be sunshine and with no cloud cover. So that can affect the readings as well. And I thought that was interesting. And so now it's getting into the forecast period because now it's on 5/29, 5/30. This goes for a week, 7 days from the beginning of the period with actual data and then forecast for the last 2 or 3 days. And there's the movie. And then it started over. And you can zoom in. You can zoom in here. See if you want to get like a closer view of a certain area. You can also just scroll with your mouse, hit the scroll key and scroll in and out. Africa has a lot right along here, and you've got a lot down here off the coast of Mexico, Central America, and then it's coming up over here on the right. But the whole northern hemisphere is like almost you can see the demarcation. It goes almost immediately from green to red. There's very little going gradually with the gold and the yellow. It almost immediately goes from green to red, from the southern hemisphere to the northern hemisphere. So you can also, like, how do you do? Okay, you can zoom in just by clicking once with your mouse key. You can also I'm a little hoarse today, so might be clearing my throat. So you can also like just hit the forward button and it'll go forward to the next reading, which is 3 hours, like that. If you just want to go really slow and look at the changes, it's in 3-hour increments. You can do that if you're looking for a specific time or specific thing that happened. And you can go backwards like that too. So that's pretty helpful. So there's that I wanted to show you. So let's look at, I want to show you sulfur dioxide really quick, and then we'll look at the methane levels around the world at the different locations. And sulfur dioxide is one of the main gases, toxic gases that's released from volcanoes. And I was looking at this last week in our weekly update. I briefly went to sulfur dioxide and we saw it coming off. Here's Hawaii and how it's, all red when it's erupting over there. And it's not even, the volcanoes are not blowing up completely. They're not huge eruptions, but it's enough to release the sulfur dioxide into the atmosphere. And I also noticed last week there was sulfur dioxide being released in northern Siberia, and so that's why I did the whole sulfur dioxide video on Wednesday. And it was pretty interesting. And so this affects our atmosphere as well, and when it gathers up into the atmosphere, it does create a cooling effect. So but it also creates sulfates, and then when it rains you get acid rain, and when the acid rain comes down on the snow and ice up in the Arctic, it makes it melt faster, this and that. So it's not good. So let's make our movie from the 23rd. I have something really interesting to show you. Okay, it's going to load. This is the Solomon Islands down here. This is Vanuatu. That's kind of got constant eruptions going off. You've got your ring of fire here, whole ring of fire. Okay, did you see that? Did you see that popped up here in Brazil? I had not seen that before. That popped up at the beginning of May the 25th. Actually at the 300 hour. See, okay, here we are on May 25th at 0 UTC time, and then you go forward one click and look at how that red popped up here in Brazil, and it popped up here in Siberia again. So let's go back one click. See, there's nothing here in Brazil, nothing here in Siberia. Everything is moved up and kind of spread out over the Arctic. And then we go one click forward and boom, you've got this popping up in Brazil and this popping up in Siberia, and it's redder up here in the Arctic. And so it makes me think that all these magma chambers are affecting each other, you know, around the globe, and when one goes off, it like triggers stuff to go off other places, and the magma is moving and shifting, and I mean, it's obvious the Earth is going into kind of this great transition, not just the atmosphere, but the Earth itself. And it's interesting to watch it. And then if we go forward another click, it's still down here and down here. It's still down here in Brazil and down here in Hawaii. It's up here in Siberia, and then it starts spreading out and dissipating. Slowly it's dissipating. But here it is really red again. So I just find this so interesting. You know, what's in Brazil that would give off that much sulfur dioxide? That's a lot. So let's go back to the 23rd, and we'll make this movie and let it run. Okay, here it comes. There it is. The boom. And then you see it drifting. You can see it drifting across the ocean. And I was thinking last week, or can't remember if it was last week, or on my sulfur dioxide video, I was calling this Argentina, but that's Chile. So I had to look that up. Okay, so now we're into the forecast period, and so now it's dissipating because they don't know what's going to be being released. So I just find that really interesting. So you can go to CAMS and do your own research on that. So now we're going to go to our North Pole view with methane, and the latest data is in from yesterday, Sunday, May 27th. This is the latest update. This is where we're at currently with the methane levels around the world. And then we can load the movie. You can see this is 0 UTC time, and here's our scale. This is measured in parts per billion, and here's your scale down here. Your bright chartreuse is at like 1900, 20, 40, 60. These are in 20 units increments. This, and then when it goes into the yellow, it's 1920, and then the golden is 1940, and then the orange is 1960, the red orange is 1980, then the red is 2000, and then it just keeps going. And then this black, almost black, is 75,600 parts per billion. So this is at surface level, and you can change the level here. If you want to see total column, you can do that. But this is coming up from right at the surface. So here we go. Let's load the movie. You can, first of all, you can see it popping up in the ocean here off of Europe, south of England, and really popping up in the ocean here between Europe and Norway, and it's coming up. Even though this is not red, it's yellow. That yellow is pretty high too. Yellow and gold is pretty high. So you have that a lot. It doesn't have to be bright red or dark red for methane to be releasing. It can be orange and methane is releasing. So here's the North Pole. Here's Greenland, Canada, Alaska. This is Siberia, Europe, and Russia, and then Europe and so forth. This is India, China, and East Asia. Here's the United States. Here's Mexico and Central America, and then here's South America and Africa down here. And we'll get different views as we go along. So we're going to load our movie here and see the 5-day forecast on this one. Okay, here it goes. It'll smooth out. Once everything loads, it'll smooth out. Okay, here we go. This one's moving faster than the big view. And when you see the red get more on one side of the earth than the other, that's when it's daytime. Because when it's daytime, it heats up the earth, and then more methane is released. And if you missed my first methane video back in April, go ahead and find that. And I talk about where methane comes from, the different sources of methane, There's a lot coming up out of the melting permafrost. They're really worried about the melting permafrost and the ice that's melting in the Arctic areas, and that there's methane that's stored in the permafrost and under the sea, the frozen sea, that's been stored for like up to 1 million years, and it's like gigatons, up to 50 gigatons of methane that could be released instantly, that would really do us in. And methane is flammable or combustible. It's natural gas, and it'll kill you in high enough quantities. So there's that view. You can see it. Let's go back a few days. Let's go back to Thursday and see how it was on Thursday. Okay, here's Novaya Zemlya, and here it is coming up off the island. Wait, let's go back to Thursday. Gotta set it at 0 there. So let's run this movie. Yeah, you can see it popping up in the Arctic Sea there. It is popping up, and that's frozen, so it's coming through the ice. There are cracks in the ice where it's coming up, and this is yellow here, so methane is seeping up through the ice as well. Methane is also one of the gases that's released in volcanoes. Carbon dioxide is a big one, along with sulfur dioxide, and then methane, and then a whole bunch of others. There's about 10 toxic gases that are released in volcanoes. Let's get a closer view of the Arctic. You can go to Arctic, and then let's reload let's reload this to 0. And we can see what happened this week. Like, we're still at the base time of Thursday, and you can see here's the Arctic Sea. Here it is. It's all like on the edges there. Here's Alaska, where the permafrost is melting and it's coming up. And you also have some volcanic and geologic activity going on up here in Alaska. So there's a lot of stuff going on. So let's load this movie from Thursday. And then we'll load it with the most recent information and do our forecast and see how the methane is expected to be coming up in the next 5 days. Okay, it's almost done. Here we go. Wow, look at Alaska. It's really heating up. Look at that. Did you see that? Okay, we'll let it run through again. Look at this here in the Arctic Sea. And look at off of Norway. There's a lot. And there's a lot in Siberia, and it correlates to the area in Siberia where the sulfur dioxide was coming up too. So it makes me wonder what's really being released, what's really happening in Siberia. And I've had some comments, people thinking it could be forest fires. I looked and it's not that. Or thinking that it's heavy industry. Well, in the research that I did, it said that China had the most sulfur dioxide emissions. China, and it's the most industrialized, and they're not using more advanced methods of burning and utilizing the sulfur dioxide. North America uses more advanced methods, and so the sulfur is not as released as much into the atmosphere. And so I just can't imagine that there would be that much industrial activity in Siberia that would be releasing that much sulfur dioxide. I mean, it's bigger than what's coming up out of the volcanic activity in Hawaii. So that's just my thought. Just makes me wonder. So there's the Arctic view. So we'll go to yesterday with the most recent activity or recent data. Wow, here's Canada. They've got a lot of permafrost there that's melting. And we'll load this movie. And what happens as methane's being released, it disperses breaks up into different things as well, including carbon dioxide, and so it creates a self-reinforcing feedback loop so that it heats up the atmosphere even more. And with the atmosphere hotter, it holds more water in the atmosphere, and so that's why when we're having storms, we're having these superstorms, and we're having bigger storms in the atmospheric rivers, and more hurricanes, and the hurricanes are starting earlier in the season is what you're seeing. And it's because it's all heating up. And so we are in the beginning stages of abrupt climate change. That's what the climate scientists are saying, that we are in the very beginning stages of abrupt runaway climate change. And with this, we'll have very weird weather. Parts will be drought stricken, where other parts will be getting floods, and it'll be cold in areas where normally it's warm, and vice versa. Everything is just out of kilter and out of balance, to the point where it's going to be hard to grow the food, grow the crops that we need to feed 7.6 billion people on the planet, which the population is growing every day, and we just are not going to be able to sustain everything. So everything's going to be falling apart really quick, really, really, really quick. And climate scientists are predicting that we could have an ice-free Arctic this summer, in which case everything will heat up even that much faster. And so even if it's not totally ice-free this summer, it's going to be bad enough. I mean, you can see things falling apart all around the world, and it's going to hit all different levels. So from this movie we can see lots of methane popping up off of Novaya Zemlya, lots of methane up here by Norway and England from this view. Methane on the East Siberia ice shelf is still seeping up and on the coastlines. Methane in Siberia popping up. Here's these, you can see it on the coast here. And the climate scientists are really worried about these coast areas because there's a lot of sediment that has, decaying plants and things like that. And that, did you see that there? That's off of the East Siberia ice shelf here. So that's not looking good. Look at Alaska. And this is only May. We're almost at the end of May. So we're heading into hot season, summer, for the northern hemisphere. So I expect this summer to be not good, a lot worse than last summer. Let's look at the West Tropic. We'll get a western view. Okay, this is South America and North America. Wow, look at the methane coming off of Argentina. Now, we haven't seen that before. Let's go back to our base time, which is today. We have not seen it way down here before, and look how it's, coming off there. Let's run this movie. That's disturbing. Okay, here it goes. Look, wow. South America is really got a lot of methane being released this week. Last week it wasn't that bad, but like the lower areas are releasing a lot. And of course you've got North America that has quite a bit. It doesn't look as bad as last week. Let's change our base time to Thursday. And let's go back to the beginning of that base time and see where we're at. Yeah, there's a lot down here in South America, a lot up in Canada and northern United States. So let's run this. Okay, here we go. Let's watch this area down here. Look at that. It looks like it's trailing. That's where it's trailing in the atmosphere, I'm thinking. But there's a lot just popping up in South America. a lot in Canada. Look at that. And then you can see the line where it goes from blue to green. Again, just like with carbon dioxide, it almost immediately goes from blue to green, from the southern hemisphere to the northern hemisphere. And this is the equator right here. So there's that. Now let's change our area to the east tropic. We'll get the eastern side of the planet. Okay, here's Africa. Here's Saudi Arabia, Middle East area, India. Let's go back to the beginning of that period. China, and then we get Indonesia and these islands over here. So we get a really good different view here. Our base time is from last Thursday, so let's run this movie. Let's see what was released. Okay, here we go. Wow, Africa is still heating up a lot there. That's pretty severe, it looks like. Look at all these islands. There's a lot of volcanic activity on these islands as well. So it could be coming up through the volcanoes and the earthquake activity down here. So there's that. And let's run it from our recent data from yesterday. We'll run the movie. It's got to load up. I'd like to thank all of my subscribers and thank everybody for watching and listening to these videos. I'm going to try and do these weekly updates if I can. Some weeks are busier than others for me, so I may not be exactly within a week. It may be like 7 or 8 or 9 or 10 days, but I will continue bringing you this information and other information too as time goes on, because we need to see what's happening, and we can see everything heating up. It's going to be affecting, you know, like the hurricanes and also the fires, and it's going to be, you know, everything plays into everything else. And so the more we understand, the better prepared we'll be for whatever happens. I don't think we have much time left. I really don't. It's just a matter of time that that huge populations are not going to be able to survive, and there won't be anywhere to go. You can see, where are you going to go? The whole planet is screwed. And if you do go south where it's a little bit better, you know, it's only a temporary fix. And we're so interdependent with each other on the globe. And if the northern hemisphere goes, you know, the southern hemisphere, it's going to go, it won't be able to stay industrialized the way it is. I mean, we import, we export from all the different countries. We are totally interdependent on each other. So, you know, some climate scientists think that all humans will be gone. Others will not be able to survive. Others think that, you know, we will be able to survive, but we'll be thrown back to a Stone Age type existence. But then you've got all the nuclear power plants that are going to go off, because if you don't have electricity, you can't cool them. So it's a mess. It's a mess. So, and we're all here studying this because we love Mother Earth. We love the planet, and we're grieving because of what's happening. So I think that's enough of that. So you get the idea. Let's look quickly at Climate Reanalyzer and we'll wrap it up. This is Climate Reanalyzer. Let's go to today's weather maps. And here are the temperatures for Monday, May 28th. This is Celsius. These are the temperatures around the globe. Looks like things are heating up. And if you want to know how, you know, what 30 degrees Celsius is, I've got a chart here. This converts, like 30 degrees Celsius is 86 degrees Fahrenheit. For those of us in the West who don't know Celsius. So 30 degrees is 86 degrees. So it's the end of May, and it's hotter than that in a lot of places here, and a lot hotter than that in places in Africa, and I think Pakistan is having a heat wave. And 86 degrees, and okay, let's look at what the green is, like 10 degrees Celsius. That's above freezing. And here's the Arctic. Here's the Arctic Sea. And so that's all. The ice will be melting. The ice is melting with it warm like that. So 10 degrees, let's find 10 degrees Celsius is 50 degrees Fahrenheit. So it's 50 degrees up here in the Arctic. Where it's green. It's 50 degrees up here in Canada, where all that permafrost is melting. Here's your temperature anomaly map that shows, like, this is the difference in temperature from what it normally is. like where it's brown like this, that's 10 degrees warmer up here. Look at Norway. Here's the Arctic. Look at US. It's 10 degrees centigrade more warmer, and in Fahrenheit it's warmer. It's a lot warmer. So you can see your precipitation and clouds, so you can see what's going on around the planet. Here's Novaya Zemlya. Here's Greenland. You can see your wind speeds. The higher the wind with the warmer temperatures, the faster this ice is going to be melting. Sea level pressure, precipitable water. This is like rain and snow. 50 HPA geopot height. I don't know what that means. Here's your jet stream wind speeds. And your jet streams get out of whack with this weird climate change. Here's your snow depth. This is in centimeters. Snow depth in centimeters. Sea ice and snow cover. You can see it retreating up here in the Arctic, and retreating here on this side of Greenland and that side, and here's Alaska. It's really retreating a lot, going up here into the Arctic Sea. Sea surface temperatures. So the oceans are heating up. They hold a lot of heat. And sea surface temperature anomalies. So this is how much like warmer or cooler the sea surfaces are. Look at the Atlantic. It's a lot warmer than it should be. And all your water areas are warmer. Almost. You've got a few that are cooler, like up here. But look, here it is in the Arctic. Sea surface is much warmer than it should be. So that's our show for today. I will try to keep you updated with the good news and the bad news. Time is short. I recommend people get their spiritual houses in order. Time is very short. Until next time, my name is Margo. I'm a hypnotist, holistic life coach, empathic spiritual healer. My website is margoshealingcorner.com. And so I hope everybody goes in peace. And God bless. And I'll talk to you next time. Goodbye.